First, we're going to make the assembly using a rack and a pinion. You can find those parts in the Lab 6 folder. There's a rack. You can download from here. And here's another one, it's a pinion. You can download from here using 3D solid model. And you can also get detailed information about pitch diameter, shaft diameter, outer diameter, the width of the teeth, okay, and so on. And also there are some specifications it's being provided here. You can also check the specification here. Okay. Once you download those parts, then you will be able to create your assembly. Let's get started with a new assembly. Okay. And because my parts are all in millimeters, I'm going to use millimeter as our default unit system. Let's save this file as a lab 06 rack pinion assembly with an initial. Okay, now you can add components. Find those components in your download folders. Browse it. I know it's in my downloaded folder. Hit OK. So I'm going to put it here. As usual, this one is the first one, so it's fixed, right? You will not be able to move it anymore. And this one is floating. Okay, we are going to make the first one to make the rack stationary, and while the pinion rotating on this rack and move along the rack back and forth. Since the rack is stationary, so we simply make it fixed, right? Fixed. So the only part we need to make its correct position is this pinion. So what we can do here, first from this joint we know the diameter. We know that diameter, pitch diameter is 50, and also the pitch height is 9 millimeters. So that means from this bottom to this center should be the pitch diameter should tangent to this line, pitch line. Okay, so then from here to the center of my pinion will be 25 plus 9, which is 34. So first I'm going to make this this position to make it so. Use the advanced standard method with your width. Okay, so this width, this face, and also this face and this face to be centered. Okay, to be centered. Hit OK. And now I want to position, make the pitch diameter tangent to this pitch line. So we know the distance. We know the distance of my center line to this bottom is 34 millimeter, right? So, and let me look at it from the front view. Okay, so it's been positioned. However, this gives center to center, right? So we would like to make something like this, right? The center, okay. Yep, this is correct. So if in case you have a different you have different location, then you need to make adjustment using these options. Okay. Now accept the mate. All right. So look at from the isometric view. We can see our part can only be moved along this rack direction, which is good. And I can also make it rotating, right? Make it rotating. Okay. So currently I have 2 degrees of freedom, and I have 0 degree freedom for the rack. It's fixed, and I can rotate my pinion, and I can also move my pinion. Okay. With my position being properly put, then we can start to make our gear. This rack, pinion, mate. So I can choose this bottom edge and my rack, and I can choose my gear. You can choose any of this diameter, right? So okay, so it's a rack, and I know my pinion pitch diameter is 50. Hit OK. Hit OK. Hit OK. All right. Now, if you check, if you rotate, it will go along the rack. But there's one thing we would like to do is to make the position more precise, right? So the taste is not matched very well. So what we can do here, we can suppress this and then make adjustment, remain. Okay. Okay. All right, looks good to me. Now, then I can save my file, and then unsuppress my mate. If I rotate again, well, perfect. So I'm going to put this pinion on this position, and then use isometric view. Okay, well, we're ready to make our motion simulation now. Let me save it. Okay. Go to motion, study, and now we are going to make a motor to drive this one. So say if we have a rotary motor, say constant this is constant speed, so let me say maybe oscillating, right? So, and here's a 90-degree. We can see from here, this is a 50, and this is a 300. That means I need to rotate say 5 revolutions to reach 250 millimeter. So I'm going to give say 900-degree, right? Try 900-degree to see what's happening. Accept, and say we would like to make this one to be 15 seconds, and do calculation. Okay, good. So I need to make a modification. We know if it is 5 revolution, it will be 1800, right? So okay. Try again. Goes in the other way. Interesting. Okay, so let me reverse direction. So if it's to see what's happening. Yes. Do calculation. Good. Alright, so this represents a stationary rack and with a rotational pinion being driven back and forth along the rack. Okay, we can save the file. Next, we're going to look at if we can fix the position of the pinion, only rotating my pinion, and then drive the rack back and forth. First, we need to fix the axle of the pinion. So let's say make a sketch, and say the sketch is to be not front but the right plane. Okay, right plane, and sketch. Okay, here's my origin, right? So I'm going to look at the right view. Let me hide those parts, those components. so we can see more clearly. Alright, here's my position. I'm going to make a center line. Alright, and then go to assembly. Let's go to isometric view and show the, here's a rack. Here's okay. I'm going to say keep this one, right? So, and keep this one. The distance also keep this one. The only thing I would like to add one mate. So my center of my shaft and the hole and the will be concentric. Hit OK. Add this mate over the assembly. I need to one more thing first to make this floating, and then I can make this surface concentric with my center line. Hit OK. Let me see. From front view, perfect. However, I'm still be able to move back and forth, right? So I want to make say my face is coincident with my front view, which is good. And one more thing, because this is moving, right? So I need to make sure, say, make my rack parallel to the top plane. Okay, so then parallel my top plane and the rack. Hit OK. Now look at from the isometric view. Okay, now you can see I will be able to rotate my pinion now, but the pinion will not be able to move back and forth, right? It's only have 1 degree freedom, and the rack only have 1 degree freedom. Okay, so perfect. I'm going to save it and drive this to this location, and this time I'm going to make my rack being driving. Okay, move back and forth. I'm going to define this, save it again, and say put isometric view. Let me hide this sketch. Okay, create a new motion study. Okay. I'm good with this, so this time I'm going to use my rack as a linear. Sorry, I should use this edge, so it move back and forth. Constant speed, nope, I would like to oscillating, and the length will be 300, right? So I'm going to use 250 1 Hertz. That's okay. So let me try it, and then I would like to try 15 seconds again to see what's happening to the calculation. Okay. Okay, so that's the simulation. We can save the file. Okay, this is the basic procedure to create a rack pinion motion simulation. There's a couple of things we would like to pay attention to. First, you want to make sure both components have the same modular. Alright, so and also the pitch diameter should tangent to your pitch line in the rack. Okay, so based on those information provided by the detailed drawing, you will be able to find the distance, center distance from the distance from the center point to the either the pitch line or to the bottom of your rack. If you would like to use other pairs of gears, then you can go to gear and search for your, either use inches or matrix. Okay, so if you use a matrix, then you should have this, you should use the same pitch, right? The pitch must be the same, or in other words, the model should be the same. Okay, and also the pressure angle should be the same. In our example, both of the pressure angle is 20 degree. Okay, let's see. I think it's 20 degree. It's a 20 degree. Okay.